When managing capacity and expanding through buying equipment or adding space, a break-even analysis has to be performed to know when the company will get their money or their investment back and start making profit. So the break-even analysis is a technique for evaluating process and equipment alternatives. The objective is to find the break-even or the point in dollar and units at which cost equals revenue. It requires estimation of fixed costs, variable costs, and revenue. The fixed costs are the costs that continue even if no units are produced, such as depreciation, taxes, debt, mortgage payments, and other costs as identified by the company. While the variable costs are costs that vary with the volume of units produced, such as labor, material, and portion of utilities. The revenue function, which is the number of units multiplied by the price of a unit, will begin at the origin of the graph and proceeds upwards to the right, increasing by the selling price of each unit. The point where the revenue function crosses the total cost line is called the break-even point. This figure shows break-even analysis and the break-even or crossover point. At that point, you can see that total cost and total revenue are equal. Remember that this chart was developed based on certain assumptions that might not apply in real world. This can be considered as a limitation for using this type of break-even analysis model. And we have to consider that we don't know all information with certainty. Or the money value will change over time, and that was not calculated here. And the hypothesized linear relationship hold only with a range of production volume. The chart and the break-even analysis will enable us to calculate the break-even point in units and in dollars, which means we can identify the number of units that should be produced to break even with the associated cost. The calculations will be done through equating the total revenue with total cost. The total revenue can be calculated by multiplying number of units produced by the price per unit, while the total cost can be calculated through adding fixed cost to the variable cost. With little algebra, the number of units required to be produced will equal the fixed cost divided by the price per unit, or the price of one unit, minus the variable cost per unit. With algebra also, we can identify, or we can find the break-even point in dollars, which will equal the fixed cost divided by 1 minus variable cost divided by the price per unit. The profit will equal the total revenue minus total cost, which will not show up until revenue starts exceeding the break-even point. So for this one, it will be in negative as long as the total revenue is less than the total cost. Once this one exceeds the total cost, at that point it will be positive and you start showing profit. In this example, with fixed cost of $10,000, with $10,000, direct labor of $1.5 per unit, the material is 75 cents per unit, and $4 of sales price per unit. Using the break-even formula, the break-even point in dollars will be around 22,857. The break-even point in units using the previous formula will equal to 5,714 units. So this is the number of units that will be required to break even with the cost and this is the dollar amount that will be required to break even with the cost. Once I have these values, if I have any of these values identified, then once I have this number, after that, any production after that will start making profit. Uh, this slide shows the chart for the total cost and total revenue for the example, and you can see the intersection point for the total revenue and total cost in the chart, and the calculation of the 5,000. You can see that the 5,714 is around here, and the 22,000 is around this area. So this is the break even in units and in dollar amount. The previous calculation and example was for a single product, and most of the companies, they don't have only single product. They will have more than one product and with different dollar sales percentages. You will see some of the products that will be sold the most, some of them will be sold less, and so on. So with multi-product case, the break-even point in dollar will equal fixed cost divided by the sum of 1 minus variable cost per unit divided by the price per unit multiplied by the dollar sales percentages. So we need to find the percentage of sale for each product and then multiply by the factor that we have, adding all that to the different products, and then find the break even for the company. This is a multiple product example which addresses products such as sandwich, drink, and fries. So basically we are talking about a restaurant here that will sell these three products. The table in this slide shows the annual forecasted sales units, the price of each unit, and the cost of each unit. So we are selling annually 9,000 units of sandwiches with a price of $5 and the cost of $3. Drinks 9,000, price of 1.5 and cost of 50 cents. Baked potato of 7,000, price of $2 and the cost of 1 cent. The percentage of sale can be calculated by dividing the annual forecasted sale in dollars for each item by the total of the annual forecasted sales. So if we divide the 45,000 divided by the 72,500, we will get the 62.1% shown here, and so on for the other values. The weighted contribution will be calculated through multiplying the column 6. If you multiply column 6 by column 8, then you will get the weighted contribution of each product. And with that weighted contribution, we can add to get the summation and then divide the fixed cost by those values. So it will be fixed cost divided by the summation, which is here, the 0.47. And this one, the fixed cost is per day. So to get it for a year, we multiply, or by month. So to get the annual, we multiply by 12 months, and to get the break-even dollar amount, we divide by the annual fixed cost by the sum of distributed weights, and that will equal to 76,596. Dividing that by 312 days, assuming that the restaurant will work only 6 days during the week, then the daily sales equal $245. To break even, any sales above that will be considered as profit. So the limit for us is $245. This is what the break-even point. We need to sell more than that to make a profit. To change and achieve the proper capacity that meets customer demand, we have to consider lots of factors. Some of these factors are hard to measure and quantify, such as the technology that will be used to increase capacity, and what are competitors doing, and how can our company be better or compete with them. How can we overcome some of the restrictions, especially building restrictions? What will be the cost of capital? When increasing capacity, would I be able to find skilled personnel to meet that increase? What regulations and rules do we need to adhere to and overcome to just increase the current capacity that we have? Again, if you think of all these factors, you can see how hard to identify a way to measure and quantify each one of them. Additional complication will be added when comparing demand growth, which is in small units. Usually, if you have a demand, you will have it like for 20 items, 100 items more. While if you want to expand your factory, you are expanding, like adding a whole line that might add thousands instantaneously. So how would that large increase be addressed when you have only a small amount of increase in the demand? This adds risk to capacity expansion decision, of course, and to reduce that risk, incremental change can be made, and there are four approaches to new capacity expansion. So you can increase capacity through incremental expansion, getting capacity ahead of demand through several steps. Or you can do it through one step. You can increase capacity through incremental expansion, but keeping your capacity behind or lagging demand. Or the fourth option is to increase capacity incrementally, but keep the average capacity within the demand range, which means sometimes capacity leads and sometimes lags demand. The several steps incremental expansion requires capacity to stay ahead of demand. A new capacity in period 1 will handle demand until the beginning of period 2, then a new capacity will be added to get to period 3 and so on. The upper management could be to make one large increase, could make a decision to make one large increase at the beginning of period 1 to satisfy demand all the way until the beginning of period 3, which in some cases could be beneficial, providing flexibility to maintain machines, have time to set up machines, to change the product, and running short production runs. In service, it can provide additional time to perform other tasks and services with flexible schedules. For example, more rooms in a hotel will provide flexible cleanup schedule. When increasing capacity through incremental expansion but keeping capacity lagging demand, other methods and strategies can be implemented to fulfill customer needs or demand until capacity catch up with that demand. Some of the common methods used to meet demand until an expansion implemented is to use shifts or overtimes, or to have some contractors from other companies to fulfill that demand. Building capacity with average that might be sometimes lags demand or sometimes lead demand. That's another option, and for that option you can see that we keep our capacity within the range of the demand. For the lagging option and for building your capacity within the average, all the two options, both of these options have the advantages of delaying capital expenditure or capital investment until you're sure of the demand and stability of the demand. Another method to determine the capacity and the decision of expansion is to apply the expected monetary value and compare alternatives. To do that, we need to determine the future demand and market favorability. Then we assign probability values to demands and sales and calculate the expected value for each option. This slide shows an example of selecting the expansion option based on the calculated expected monetary values. Southern Hospital Supplies is a company that produces hospital supplies and looking to expand their capacity, but have three options to select from: adding another small plant, or adding another medium plant, or adding a large plant. There is a 40% possibility of favorable market and 60% possibility of unfavorable market. With favorable market, the profit of the medium plant will be 60,000, while if the market was unfavorable, the loss will be 10,000. So with unfavorable market, we lose money. With favorable market, we gain money, or we have a profit. And with 60% chance of loss, we need to select one of these options, one of these plans, to make our expansion. So you can see with the medium plant, the monetary expected value will be positive 18,000. For the large one, it will be negative 14,000. Basically, we are losing money. While for the small one, we will be positive, gaining money, but 13,000. So based on these calculations, the medium plant will be selected, and the decision will be made to make a medium plant. We don't want the small, we don't want the large. Although the small one, still we are gaining, we are doing the medium plant, so we have always flexibility of expanding more. So still the company has the option of doing nothing, which will not cost anything, but at the same time will not gain the company any profit and might affect their competitive advantage over the long run. Operations managers may have to deal with expansion as an investment and should be considered within other financial options. At that point, analyzing capacity alternatives should include capital investment, variable costs, cash flows, and net present value. The net present value will allow considering time value of money and the interest rate applied to the capacity expansion decision. We can bring all future values to the present and compare the net present value for all available options, then decide on an alternative solution. The formula shown in this slide will be used to calculate the net present value for alternatives. While this works fine for some cases, it might not be reasonable for larger values of n, like number of years for investment. When it goes above certain number of years, it will not be feasible or reasonable. The 1 divided by 1 plus I to the power n is a factor that can be either calculated mathematically just by using the value of I and the value of n, calculating with the future value, you can get the present value, or you can use the table shown in this slide. You have it in the book, where n is the number of years in the first column and the interest in the other column. So you have here the 6%. The first column is 6%, and then we have the 8%, 10%, 12%, and 14%, and those are the number of years. So for 1 year, for n equal to 2, for n equal to 3, for n equal to 4, and n equal to 5. You could invest in an expansion where you have to make annual payments or uniform equal payments. The present value can be also calculated through multiplying the annuity by a factor x, which can be found from the table shown in the next slide. But also This factor also can be calculated mathematically once we are given the equation for that. So, and the equations, all these equations and the present value and the annuity is being taught in engineering economics analysis course. And that's why we have that course to support the calculation for capacity, demand, and forecasting. The table on this slide shows the value of the annuity factor with different interest rates and for different n or number of years. And as we said, we have different interest rates, different columns for the interest, and different rows for the n number of years. Uh, This example is about River Road Medical Clinic, which is thinking of investment in a piece of equipment that will generate 7,000 per year for 5 years, considering an interest rate of 6% and the value of the factor of, at 5 years, which will equal from the previous table 4.212. So multiplying that with that 7,000, the present value will be 29,484. So we compare that with the present values of other alternatives. If this value is good, then we will go with this value as our option of selecting that equipment. Some of the limitation using the present value analysis that to compare alternatives might have those alternatives might have different projected lives and salvage values, which has to be considered in the calculations if we do so. Investments with the same net present value might have different cash flows too. In addition, this method assumes that we know future interest rates, which might change due to other related factors. We can assume that the interest rate is 6%, maybe over 2, 3, 4, 5 years, but maybe after 10 years, that we cannot guarantee that the interest rate will stay the same, and it might change again due to political, social, or other involved factors in the economy. These calculations assumes that payments are made at the end of each period, while it might be required to be paid at the beginning of the year. If these limitations can be controlled, the net present value will be a good technique to use to compare alternative expansion options. And again, this is one of the methods that can be used to make that decision. With that, that will be all for this session. If you have any questions or concerns, please let me know. Thank you and have a great day.